Balancing hard redox reactions. Balancing hard redox reactions will work the same way as balancing easy redox reactions. The only difference is the problem is longer. For example, the following is a harder redox reaction. We will balance this reaction using an electron transfer half reaction method used to balance the easy redox example. Lead 2 sulfide, PBS, plus nitric acid, HNO3, plus hydrochloric acid, HCl, yields lead 2 chloride plus sulfur plus NO, nitrogen monoxide, plus water. First, assign oxidation numbers to each element and each element in a compound using the oxidation number rules. Thus, lead is a +2 because sulfur is a -2. In the nitric acid, hydrogen is +1, oxygen is a -2. 3 times a -2 is a -6, so nitrogen in nitric acid is a +5, HNO3. In the hydrochloric acid, hydrogen is +1, chlorine is -1. On the right side of the equation, lead is a +2, chlorine is a -1, sulfur is 0. In the nitrogen monoxide, oxygen is a -2, so nitrogen must be a +2. And in water, hydrogen is +1, oxygen is a -2. Look for the two elements with a different oxidation number from the left side of the reaction to the right side. The two elements that change oxidation state are nitrogen and sulfur. Nitrogen goes from a +5 to a +2, and sulfur goes from a -2 to 0. In all redox reactions, one element becomes more positive and one element becomes more negative. Make half reactions showing the electron change from one side of the equation to the other side of the equation. The half reactions are nitrogen goes from a +5 to a +2, a 3-electron change. Sulfur goes from a -2 to 0, a 2-electron change. If the electron change is not equal, find the least common multiple, which in this example is 6. 3 electrons times 2 electrons is 6. Multiply the first half reaction with nitrogen by 2, because 2 times 3 electrons is 6 electrons, and multiply the second half reaction with sulfur by 3, because 3 times 2 electrons is 6 electrons. Use the coefficients found above in the original equation and check to ensure all atoms are balanced. Now, when you balance equations, remember you start with metals, then nonmetals, hydrogen next to last, and oxygen last. And you will notice that lead here has 3 on the left and only 1 on the right. So I have to adjust the equation by putting a 3 on the left and a 3 on the right. So my balanced equation is 3 PBS, lead 2 sulfide, plus 2 HNO3, nitric acid, plus 6 HCl, hydrochloric acid, yields 3 PbCl2, lead 2 chloride, plus 3 sulfurs, plus 2 nitrogen monoxide molecules, plus 4 water.